This lesson is on looking at the slopes of parallel and perpendicular lines. It follows the last lesson on writing equations of lines, so we're going to focus on the slopes of specific kinds of lines today. The equations of lines that we have used is either the slope-intercept form or the point-slope form. Both are used with parallel and perpendicular lines as well as not horizontal and vertical, because remember those are special equations, y equals and then x equals. But with parallel and perpendicular lines you can use either one of those equations. Okay, so slopes of special lines. So if two lines are parallel, then they will have to have the same slope. And that makes sense. Remember that slope is how fast a line goes up or down. So if lines are parallel, they have to be changing at the same rate. They have to be going up or down at the same slope. Perpendicular lines, they're going in completely opposite directions, okay? As opposed to parallel lines, perpendicular lines are going in the opposite directions, so their slopes are opposite reciprocals. That means that they have the opposite sign. If one is positive, the other one's negative, and they have the reciprocal, which means that the fraction is flipped. Slopes are almost always given in fractions because it's the rise over the run, so you simply flip the fraction over to get the reciprocal. Horizontal lines have a slope of 0. That's why it's just y equals a number. There's no slope there. Or the slope is 0, so it cancels out. And vertical lines, the slope doesn't exist because you're rising over 0. Rise over run, and your run is 0. So that slope doesn't exist. And that's why those two don't have the same kind of equation. They can't follow this equation like parallel and perpendicular lines do. They have to have their own special equation. Okay, so given this information, that parallel lines have the same slopes, perpendicular lines have opposite reciprocal slopes, horizontal lines and vertical lines, their slopes are always opposite each other. Horizontal and vertical lines are always perpendicular to each other. So if you get equations like that, then you'll automatically know that those lines are perpendicular. Let's look at some examples of diagonal lines to look at whether or not we can tell those lines whether are parallel or perpendicular. So to find the slope, remember we do the change in y's over the change in x's. So we're going to do y2 minus y1 all over x2 minus x1. I'm going to do 6 minus 5 for my top. Those are my two y values. So since I'm doing 6 minus 5 on the top, I have to do 4 minus negative 1 on the bottom. So my slope for this, the equation or the line that contains those two, would be 1 over 5. That would be the slope of this line. 6 minus 5 is 1. 4 minus a negative 1 would be 5. So the slope between those 2 points is 1/5. Now I'm going to find the slope between these 2 points. And in this case, I'm going to go this way. I'm going to do 12 minus 7. And why would I do that? So that I can have a positive number on top. And in that case, I have to do 0 minus negative 1, or 0 minus 1. And in that case, my bottom value is negative 1. So I have the slope between these 2 points is positive 1/5. The slope between these 2 points is negative 5 over 1. If they are the same, my lines are parallel. If they are opposite reciprocals, then my lines are perpendicular. If they don't fit into either one of those categories, then they're just intersecting lines. At some point, they're going to intersect, but not at any special rate. Okay? In this case, these are opposite reciprocals, so we would say that our lines are perpendicular to each other. That's the symbol for perpendicular if you don't remember. Okay? All right, so let's put this into play. Another example problem, are these lines parallel? Well, they don't really look parallel, but they're pretty close, so we should do the actual math to check. All you have to do is compare their slopes. To find the slope of a line, we simply count how much we rise over how much we run to go from left to right. I've already marked 2 specific points on there. If you get lines that don't have points specifically marked, then you have to mark them. For this one, I would count the rise as 1, 2, 3, 4. So it rises 4. And after it rises 4, it runs 1, 2, 3. So the slope of this line would be 4/3, rise over run. The slope of this line is 1 over 1. It rises 1 and it runs 1. So this one's 4/3 and this one's 1 over 1. Even if I simplify 4/3 down, I do not get to 1, which means that these slopes are not the same. So now, are they opposite reciprocals? No, because they're both positive, so they're not opposite reciprocals. And so therefore, are these lines parallel? They are not parallel. They are not perpendicular. And how do we know that? Because if they were parallel, the slopes would be equal, and they are not. The slopes are not equal. Okay. Sometimes it won't be quite this straightforward where all you have to do is count to look at the slopes. Sometimes they'll give you the equations give you the lines in equation form instead of in graph form. And in that case, you have to be able to pull out the slopes to look at them. In this case, they're not written in any kind of nice form that I can just pull the slope out of. Remember that your 2 equations are slope-intercept, so y equals mx plus b, or point slope, the y minus y1 equals m times x minus x1. They're not in either one of those 2 forms where I can just pull out the slope, so I have to put them into one of those 2 forms. The way I'm going to do that is to solve for y. So to get my y alone, I'm going to minus 4x over to the other side. So I'm going to have negative 12y equals 20. And actually, I don't really want to write the 20 first. I can, it's not a big deal. But to put it in this form, I probably should put the x first. So I'm going to minus 4x and then just put the plus 20. I could certainly do 20 minus 4x. That would not be a big deal. And then when I divide by negative 12 to get the y by itself, I have to divide everything by negative 12 because that's how the rules of division go. So I end up with y equals, and then negative 4 over negative 12 reduces down to 1/3. And this is going to be negative 1.8. 8 over 12 would be 2/3, so it's going to be 0.6 repeating. But really, we don't care about that. All we care about is the slope. The slope for this line is 1/3. That's all we're going to compare. Now we have to do the same thing with the other equation. Get the slope of it. So in this one's a little bit easier. All I'm going to have to do is minus 1 from each side to get the x alone. So it would be y equals 3x minus 1. So the slope of this line is 3, or we'd write 3 over 1 because we'd always want it to be in fraction form. So 1/3 and 3 over 1. Remember, if the slopes are the same, the lines are parallel. If they are opposite reciprocals, they are perpendicular. If they're not either one of those, then they're just intersecting lines. These are reciprocals, but not opposite reciprocals. And since they're not opposite reciprocals, we would say that they are just intersecting lines. So the relationship between the 2 of them is that they are intersecting lines. Okay. So you have to get the y alone and pull out the slope from each one to determine the relationship between them. Example 4, what's the slope of a line that's perpendicular to this one? Well, once again, they don't give it to us in anything easy, so we're going to have to solve for y to pull out the slope. So let's do that. I'm going to add 2x over to this side. These aren't like terms, so I just end up with 4y on this side, and then 2x plus 10 on this side. And then I have to divide by 4. Those would cancel, so I have y by itself. Therefore, my slope is then 1/2. 2 over 4 reduced down to 1/2 would be my slope. And 10/4 would be what? 2.5, but that's not really going to matter either because all I care about is the slope. Okay? It says, what's the slope of the line that is perpendicular to this one? Well, my line has a slope of 1/2. So in order for a line to be perpendicular to that, the slope would have to be the opposite reciprocal of it. So the opposite reciprocal of 1/2 would be negative 2 over 1, or just negative 2. That would be the slope. How about what's the slope of the line that's parallel to it? Remember the symbol for parallel? Parallel lines have the same slope. So it would our line would have to have the same slope as this one. So the slope would have to be 1/2. And that's how you'd find the slopes of lines that are perpendicular or parallel. You have to find the slope of the line you're given, and then take the opposite reciprocal for the perpendicular line, and then take the same slope for the line that's parallel. Number 5, our last example, write the equation for the line that's perpendicular to this one, and that goes through the point 4, 3. Okay? We are going to want this equation of the line for that, because the point that they give us is not the y-intercept. But we need to know the slope of our line. And our line is perpendicular to this one. So if I know what the slope of this line is, the slope of my line will be the opposite reciprocal of this one. Well, this one's already nice and neat, put into y-intercept form for us. So the slope of this line is 1/5. And since my line is perpendicular to that, the slope of my line would be negative 5 over 1. It would be the opposite reciprocal of that slope. And now I just plug it into my equation that we learned in the last lesson. So I'm going to do y minus, my y1 value is 3, equals my slope, which I just determined is negative 5. And I can write negative 5 or negative 5 over 1. It doesn't matter. And then x minus, remember, is part of the formula. And then my x value is 4. So that would be the equation of a line that is perpendicular to this equation and goes through 0.43. That would be the answer. Okay. That is the end of our lesson, and your homework is as follows.